So I will talk about volume management today. So first, a few words about the state of the art. Mainly work about the concepts of volume management in SABR or CGR, so contact graph routing, and then how is it integrated in the software. And then I will present the concepts in those two aspects, followed by an evaluation. So, first, when we forward a bundle, well, we need to care of the previous bundle forwarding decisions, which means that when we forward a bundle, we need to update the volume representation, and this can happen on a multi-hop basis. If we use a CGR, well, we have a route which consists of several contact hops, and we need to care of the volume on each hop and then update the volume on each of those hops as well after the forwarding decision. So the currently accepted techniques, by accepted I mean part of the standard or integrated into ION, are ETO. So ETO is just we have a transmission queue with the next bundles that need to be transmitted with a direct neighbor. Then we want to forward another bundle where we have to wait that the bundles in the queues are transmitted before being able to transmit the next ones. And this will calculate an earliest transmission opportunity for the first byte of this next bundle. We have then the EVL, so effective volume limit, which is the residual volume for a contact. This is basically used for filtering. When we schedule a bundle through a contact, well, we increase the booked volume, but we decrease the residual volume or EVL. And then we have the queue delay, which extends the concept of ETO, but at the hops after the next one, just by considering the booked volume and trying to calculate a delay for the first transmission opportunity for the bundle we are trying to forward. Good. So what are the possible gaps in ETO? So with the bundle protocol, we are allowed to schedule a bundle of arbitrarily large sizes, which means that if the forwarding decisions has to happen during the forwarding of a very large bundle, then we might not be able to calculate the ETO correctly. So either the large bundle here depicted in red is considered already out of the queue, then we calculate an ETO which is too early. And if it's still considered in the queue, then we will consider the whole size to calculate the ETO, and then the ETO would be too late. Another possible gap with ETO is what happens if your bundles can't be fragmented. So when you schedule a bundle for a neighbor, you might have several contacts with this neighbor, and the transmission queue volume or backlog might spill over several contacts. And ETO works well only if you can fill all of those contacts, which is not always the case, because if you have bundle priorities, you can't reorder the queues. So it might be complicated to have a very precise ETO in these kind of cases. And again, it means that the bundles are likely to be very large, otherwise, while the gap is maybe negligible. Another issue that can arise, so nowadays we use the orbitals opportunistically as relays, but in the future we plan to have dedicated relays. So we might expect those relays to have one antenna for long-range communication and one for short-range communication, which means that they can receive and transmit at the same time. And in this case, it means that along a path, an end-to-end path with several hops, you might have overlapping of subsequent contacts. If you have overlapping, then it means that you need to rely on the queue delay, but you can end up in situations where the overlapping is so prominent that you are not able to calculate the earliest transmission opportunity at the intermediary hop. So here, for example, if you calculate the Q delay for the bundle one, well, you start from the beginning of the contact. If it's during the selection, you will effectively correctly calculate the next stop transmission start time. But then when you calculate that for another bundle, well, the Q delay is here, so you are not able to see that you are supposed to transmit something at this point of time. So you end up calculating an earliest transmission opportunity, which is actually not possible. So how those things are integrated in CGR? Short answer, everywhere. In the code base, you have volume aspects in the contact plan, for example. In the contact plan, you will have at least the data rates. But if we consider more evolved volume management technique, you might want to integrate other things in the contact plan. So this is something we already do. Then maybe in the graph representation, of course, which is the direct mapping to the contact plan. In the route selection, you also want to consider the volumes if you want to drop Yen's algorithm, which is probably something we would like to do. We published a paper last year about all of the gaps we have with Yen and also the operational risk. And during the selection, then you need to consider the volumes 2 times while you try to evaluate which candidate is the best one, and then when you want to update the volumes. So consequently, modifications of the volume management technique means that you need to do modifications everywhere in CGR, which is already a quite complex algorithm. And I think it's quite a problem if you want to introduce new researcher to the field. If I have students, I want to make part of the DTN journey, and they have to learn CGR first. Well, they don't have much time to actually contribute efficiently. It's only a 6-month period, sometimes not full time. So having something to ease the process of introducing new researcher could be interesting. And also, most of those volume management techniques are currently hard-coded, although we want to have different techniques at different locations. And this is already the case. So we have ETO for the first stop, and we have other techniques for the next stop. But there might be some cases where we want different volume management techniques at the same location. So for example, for the first stop. And also, I don't even talk about priorities. Now priorities is not part anymore of BP v7, was dropped, passing from the version 6 to version 7, but we might see it back with some extension blocks. So for the volume management itself, what do we propose? Well, we could track accurately the utilization of the contact in a timely way. So here you have in green the time interval of bandwidth availability, and when you try to schedule the bundle, well, you calculate transmission start time, and you just reduce a time segment if you are transmitting from the beginning of the segment. If you need to transmit the bundle a bit later, then you would just cut and have 2 segments after this process. And what happens for the first case also happens for the segments which are after the first one. Here, this is just for visualization, so I have segments for the bundles themselves, but this is something we only use if you want to be able to reschedule a bundle and revert those changes. In the basic version, you don't even need to have segments for the bundles themselves. This would be a list with only 2 intervals, for example. But then, if you want to introduce more evolved techniques, you can introduce much more types of segments. So here we have, for example, immutable segments for the data rate variations. So right now in CGR, you would have 1 contact per time segment. which is problematic if your bundle can't be fragmented. And also it means that you would also fragment the bundle even though you have a continuous physical contact. So having this can help a bit for the management of the volume when you have more complicated contact. And we can also imagine immutable segments for the delays. Right now we use range messages, but that will be quite similar. And then for the priorities, well, we have mutable segments for aggregates to simplify a bit the process, and then we also store the bundles to be able to reschedule them. This can be way more evolved than the first example I showed. For the integration of the volume management, so as I said, we might want to use different volume management techniques at the same location. So for example, the first stop. So the contact segmentations works very efficiently if the contact plan is accurate, because we drop the vision on the transmission queue. So if you have retransmission required by acknowledgement, like some packets were lost on the CLA level, then contact segmentation can be a bit less efficient. But if you have a long range link, then just use contact segmentation. So for short range links, which are from the local node, you might still want to use ETO, but then contact segmentation for first stop with long range neighbors, then this is something which is currently not possible with CGR. So the idea is to attach a volume management generic component to the contact, which is initialized accordingly depending on the contact plan. What do you have in the contact plan? What type of contact is it for the volume management and so on? This allows to decouple the volume management from the pathfinding and selection. So this is something we are also working on. How do you make the pathfinding technique extensible as well as the storage for the routes or the trees, if you have something for multicast and so on. This reduces the effort to include new researcher in the volume management journey. So now a researcher just has to create a data structure which is only modified or checked with a reduced set of functions, which are defined by the interface. And then, well, also some sanity check for the initialization, is the contact plan accurate, and so on. This is also something that can be managed by the interface. For the evaluation, we use the IO-DTN sim, so developed by Felix Walter, on a realistic scenario, so the ring road use case, quite large scenarios, so up to more than 200 nodes, with quite a lot of contacts and also quite a lot of bundles. We also introduced one realistic transportation scenario. Why do we want to do that? Well, if you randomly generate ring road networks, well, the network would be quite homogeneous. But if you have a transportation scenario, then you have routes which are very different with some dead ends and so on, and you can see a bit more about how your volume management performs. And for the algorithm, well, we use CGR. So not the alternative for the SPSM, which is also very good. But we reduced the impact of yen just by dropping it. So we use another approach, which is the first ending contact technique. And well, we can see that contact segmentation. So here, CGR with CS outperforms so ETO and ETO plus Q delay in most cases, and quite surprisingly, also more efficient computationally. So what could also be mentioned for this aspect is that The forwarding runtime do not exclude the simulation overhead. So if the volume management is more efficient, you might have less transmission, so that could also impact the results here. But what can be assumed from those results is that at least contact segmentation is at least as good as ETO or ETO plus Q delay. And of course, all of them use the EVL filtering technique as specified by SABR. And that's all for me. Thank you very much.
Yeah. So we have some minutes for questions.
Yes.
Thanks for the presentation. I'm curious on the contact utilization. I'm curious, why contact segmentation will lead to lower utilization.
Sorry?
It seems that in the contact utilization, it seems that contact segmentation results in a lower utilization.
Yes. So the reason with contact segmentation, your routes are more accurate, so you have less rescheduling. So it means that you use less bandwidth to make your bundle reach the destination.
Okay.
Yes, probably.
Yes.
I think that's very interesting, the volume management. The question I have is, this is for the local traffic, if I understand right. So
yes.
You are not, you are improving by considering your local view, but there may be other nodes also generating traffic.
Yes.
It's more difficult to.
Yes, exactly. So, very good question. So we are in the same case as CGR, and then there are some contributions from the literature on how can we mutualize the knowledge we have with the neighboring nodes and so on. We can assume that this could also be compatible with contact segmentation, but this is not something we explore. Thank you very much.
Any other questions for Olivier?
No.
For great presentation, brief technical question on that RAS interpretation. So you said it.
Yes.
Did you actually, for those steps, use this RAS interpretation?
Yeah. So here we already use the generic volume interface with SPSM. So in the paper, in the thesis, I have results with SPSM. Here we just wanted to use CGR, which do not use the interface, and the rest implementation. So it's currently ongoing work and should be released, I hope, before the end of the year.
One more from my side, Olivier. What are the next steps in volume management? What follows?
Well, I think there will be quite some work on priority of service, and I hope that this kind of interface to easily test and implement volume management techniques could ease this work in this direction, and I would pursue some research around fragmentation. I think fragmentation is also an interesting research topic, which is quite unexplored for congestion control, for example, those things.
And for considering fragmentation and priorities, the interface that you presented needs to be modified for those, or if you can reuse the same interface?
For priorities, we use the same, because the interface takes a bundle as parameter, so we can include the priority. For the fragmentation, I'm quite unsure. Maybe at the higher level, because at this point of time, when you use the volume interface, you already have a bundle. It's not fragmented, which maybe you can you can return a fragmentation STINT. Would be an option.
Thank you, Olivier, again for your talk. Yeah.